actually, if you look carefully, this circuit is actually similar to the circuit, the video that I have already made, and please refer to the video. Okay, so this is just an extra explanation on how to solve this by using mesh analysis. So this week actually we go for mesh analysis, and for the next week we go for the nodal analysis. Okay. So for the mesh analysis, so what the first thing you need to do is actually to determine the mesh current and the direction. So this is one I1 and I2. Okay.
Okay.
But please be noted that sometimes, okay, so this is AC source. So sometimes they just put this symbol like this. So this is actually AC source. But since this AC source is AC, so the positive and negative is actually can be changed. Because sometimes it is positive, sometimes it is negative, depending on the cycle. Okay, but usually if you look at our textbook, so it use this directly, use the symbol, because for calculation purpose. Okay, because in our calculation we need to identify the polarity. Okay.
So in test 2 or maybe in final, they will be
maybe in
giving...
final it will give this symbol, because I have already prepared the final exam. So this the symbol, and then with the polarity like this.
Okay.
Okay, for example, like this. Okay. Okay, so meaning that this is AC and the polarity of this. But in our textbook, they just use this symbol directly. Okay, so please be noted. So for the KVL, so we need to use KVL for mesh number 1. So I think this is very direct. So this is your voltage source plus 3 plus J4 I1 and 1 ohm multiply with, there is a current I1 minus I2. Okay, then this is equal to 0. Okay, so for this mesh current for the AC circuit, because it involves a lot of complex numbers, and my experience is better for you to actually solve this equation first rather than you go for the next KVL. Okay, so you need to simplify this. Okay, for me, so this one will become 3 plus, so this one is 4. Okay, I1, and then this one also I1 plus, sorry, this is complex number, so you need to be very careful. Okay, so 3, sorry, this is 3 plus 1 I1, so this one will become 4 plus J4, so this is all I1 minus I2, then this is equal to 10 with an angle of 0. So this is your first equation from the KVL. Okay, and the second KVL for mesh number 2. Okay, so this one, if you look carefully, if you have a current source inside your mesh, okay, just put I2, the value of the current source. So no need to have a KVL. Okay, so this is your second equation. Okay, so and then I think you can use, you can substitute. So this one will become 4 plus J4 I1 minus 2, 0. This one will become 10. Okay, stop. substitute 2 into 1. Okay, so what I substitute is actually I substitute I2 into 1. So we will have 4 plus J4 I1 is equal to 10 plus 2, 0. So this one is simply, so 10 plus 2. So this is actually, there is no what I call angle. So meaning this is, all these two numbers are real. So just add it. So this is 12 with an angle of 0. Okay. So this is I1, 12, 0. So 4 plus J4. So you can use your calculator. Make sure that it is a complex mode. Okay, 12. If the angle is 0, so I think no need to insert the angle, because you already, because it is same. If you convert into rectangular or facer, it still give you the only the number, no imaginary part. Okay, over, and then this is, you need to open the bracket, 4 plus 4i, close the bracket. So this will give you the rectangular form. So because the current we always prefer in polar form, so this will be give you the polar form 2.12 with an angle of negative 45. Okay, so I1 is 2.12 and I2 is 2 angle 0. Okay, so this is actually what I have already explained in the video. So right now, I put another extra question for you all. Okay, maybe this is actually the advantage of attending the class, extra class, where, as you can see, no students right now in this morning class. Okay, can you get me what is the value of V across these two? Satis or Tiara? Right now, you only 2 students. Satis and Tiara, can you calculate for me what is the voltage across these 2 ohm? So I think I can just try. Because in the question, sometimes they said, okay, the question like this, use mesh to find V, for example, which is V is actually the voltage across. So what you need to do is, the first thing, you need to identify the mesh current, right? So right now we have already done I1 and I2, we have already obtained. So the next question is actually this one, to find V. So how to find V after you have obtained the mesh current?
V equals to IR.
Yes, V is equal to, right now the only current that across, that flow inside these 2 ohm is I2, right? So I2
Yes.
multiply with 2 ohms. So you have I2 is to 0 multiply with 2 ohms. So this one we have 4 ampere. 4 ampere.
4 volt.
Right. Sorry, 4 volt. Okay. Understand? Okay. What if the polarity is changed? So this is actually this one. And this is Vx, for example. This is Vx. So use mesh analysis to find Vx. But right now the polarity is like this. Can you find me what is your Vx? Still the same, you need to actually identify the current I1 and I2, so which is, you have already,
-4.
you will actually obtain this current, right? I1 and I2. The only change is on the polarity. So Vx is, you can see the current is flowing negative. So meaning that you need to put this one negative. I2.
Negative 4.
So this is negative. Yeah. So this one negative 4. Just like that. As simple as that. So meaning that what you need to do for this, because for the test one, I can see that most of you, because if you recall back for the first test, I there is a question like this, right? You have the polarity like this, and then most of the students will actually do the mesh analysis by looking at this polarity first. Okay, so what you need to do is actually to ignore this Vx and so on. So just use the original mesh. So just ignore, you just ignore the polarity and so on. Okay, just assume that all the current are entering the positive terminal of this. Okay, but for this,
Okay,
it depends. It depends. For I1, because there is a two current, so it depends. For mesh current, you need to actually obtain this I1 minus I2 and so on. Okay.
Yes, doctor.
Okay, can you right now, can you find me what is the voltage? What is the voltage across the current source? For example, this one Vx, calculate Vx. Okay, so using mesh analysis, calculate Vx. So still, same thing, which is you need to identify the current, and then actually we have obtained this, which is I1 and I2. So next is actually this one Vx. So how to obtain your Vx?
R substitute with 2.
R substitute with 2. You cannot do like that because this is current source. Okay, so if you look carefully here, what you need to do is actually to obtain what is the voltage across this 1 ohm. Okay, because okay, so V1 ohm. Okay, so from that actually Vx, if you do the KVL, so negative V1 ohm, okay, plus V2 ohm plus Vx is equal to 0, right? Okay, and then so Vx is actually V1 ohm minus V2 ohm. So right now V2 ohm you have already obtained. Okay, V2 ohm is actually, you can actually obtain by I2 multiply with 2 ohm, right? Which is I2 is 2 with N2 ohm. So this one is 4 volt. Okay, right? So what you need to do is to find the V1 ohm. So to find V1 ohm, actually V1 ohm is actually so right now the voltage V1 is actually this one, positive, negative, right? Okay, so this one is I1 minus I2. Why I1 minus I2? Because we assume that the net current is entering the terminal positive. So meaning that I1 is bigger than I2. So that's why I write down like this. Multiply with the resistor. Okay. So this one is 2.12 angle negative 45 minus 2 multiply with 1 ohm. So you can use your calculator here. 2.12 angle minus 2. Okay, and then just multiply with 1 ohm. So your voltage V1 will be 1.58 with an angle of negative 1. Okay, so your Vx is 1.58 negative 101.5 minus 4. Okay, so plus minus 4. You will obtain that your Vx is 4.74 with an angle of negative 161.6. Okay.
Okay, doctor.
The super mesh. What is super mesh? Is actually if you have, for example, this is the impedance. Okay, this is impedance, and then you have another one here, a current source. So this is Z2, and then you have another one, Z3. So Z is actually the impedance. Okay, so if you have a mesh current in between two mesh current, I1 and I2, okay, so this is where you are dealing with the super mesh. Okay, so the super mesh is actually we refer to this mesh. So this is maybe this is V1 with an angle of 0. So what you need to do is actually the super mesh, the KVL for the super mesh. So you need to write down the KVL, the green color. So this one will become negative V1 angle 0 plus Z1 I1 plus directly just Z2 I2 plus Z3 I3 equal to 0. So this is your equation, and another equation is actually from
I2 minus I1.
yeah, from the current source. Okay, so from the current source, if you put I1 minus I2, so equal to maybe this one is IS. Is it correct?
No,
Not correct. Why? This is not correct.
because
The direction of the current.
not same with
Okay, yeah. So what you need to do is actually you need to write down I2 instead. I2 minus I1 is equal to IS. Okay. So this is the second equation. So as you can see, you have two variable I1 and I2 here. So sorry, this is not I3. So this is I2. Okay. You have two variables I1 and I2, and also two equations. So you can actually do the simultaneous equation. So since this is complex numbers, so your calculator cannot be used to solve the simultaneous equation, persamaan serentak. Tak boleh. You cannot use your calculator because this is complex numbers. So what you need to do is actually to do it manually. Just substitute this one I1 and substitute I2 inside manually. Okay.
Okay, doctor.
Okay, I think that's all. I am very concerned that you need to look at my video, okay? Because this is only the concept. The concept is actually, the theory is actually applicable for AC circuit. What we have learned from DC circuit is actually AC circuit. But this is AC circuit is complex numbers, so sometimes the solution will be very complicated. You look is very what I call very complex to solve because you have a lot of numbers. Okay, and sometimes students are very clumsy and careless. They sometimes forgot to actually to write down the J, to write down. They forgot to put the I inside the calculator and so on. So that's why sometimes your answer is not correct. So for this AC circuit, what you need to do is to do a lot of exercise. Okay, I have give also examples in your WhatsApp group, okay, with the solution. So what I need you to do is actually to do that first without looking at the solution. Okay, the solution is actually for your guidance to double check with if your answer is not correct. So double check with the solution where you have made mistakes. Okay, I will give another assignment from time to time. Okay, and then you need to submit the assignment through e-learning. Okay, just to make sure that you have because the assignment can be regarded as an exercise. Okay, and then I will give you marks on what you have done. Okay, so thank you very much for your attendance. Oh, I forgot to the attendance. I will actually post the attendance in the WhatsApp group. Okay, you need to scan it. Okay, Satish, everybody, Ausa, Farah, Tiara, and Zalza. Thank you very much. Okay.
Thank
So
you,
I
Doctor.
wish I will share
Thank you,
this video.
Doctor.
Okay. Okay. Thank you very much.